In an embedded system, timing is everything, from sensors in your smartwatches to airbag in a car. Devices must respond instantaneously to the world around them. In this video, we'll explore how interrupt works in an embedded system, why they are essential, and how they make real-time responsiveness possible. We will explore introduction to interrupts, interfacing of a switch using an interrupt, how to write an ISR. Okay, what is an interrupt? An interrupt is a hardware or software signal that temporarily halts the CPU's current process so that a higher priority task, the interrupt service routine ISR, can be executed. Let's understand the interrupt process. When processor receives an interrupt request, it executes the current instruction. After execution of the current instruction, the address of the next instruction is pushed onto the stack. The program execution is transferred to an ISR. ISR is called interrupt service routine. ISR contains the task or program corresponding to the interrupt. The address is stored during the after completing the ISR, the address stored during the push operation is popped from the top of the stack. The processor resumes its normal operation. Interrupt can be generated by different sources. The interrupt can be generated by external hardware devices or internal hardware. So for example, the interrupt can be generated by a push button switch connected to INT0, INT1 or INT2 pin. Similarly, a timer can generate overflow interrupt. An I2C or SPI module can generate interrupt on transmission or reception of the data. Similarly, the interrupt can also be generated by UART or USART module. So there are total 21 interrupt sources in Atmega 16 microcontroller. Now let's understand how to enable the interrupts. So interrupts enabling process could be different for different microcontrollers. In this video, we are considering the Atmega 16 microcontroller. So in the Atmega 16, the interrupt enabling is a two-step process at the global level and local level. First, we have to enable interrupts at global level. Then we have to enable individual interrupts at local level. So to enable interrupts at global level, we have to set the bit number 7 of SRAG register. This is done using SCI instruction. The I bit or the bit number 7 of SRAG register is cleared by the hardware after an interrupt has occurred, and it is set by the RETI instruction to enable subsequent interrupts. Now let's take an example. Okay. In this example, we have connected a push button switch to one of the interrupt pin. So we have INT0, INT1 and INT2 pins. So we are generating external interrupt request by pressing the switch. We have also interfaced an LED to one of the GPIO pins of the microcontroller. Our objective is we want to toggle the LED whenever the switch is pressed. So the interrupt request is generated whenever the switch is pressed. Okay. Okay, now let's understand the programming part. So first we have to include the header files, and then we have to enable the interrupt at the global level by calling the SCI function. Now we have to enable the INT node. So for that we have to configure GICR register. After that we have to set the signal level for the interrupt. So we have 4 different possible options if for the interrupt. So for that we have 4 different options: 0, 0, 0, 1, 1, 0 and 1, 1. So if we configure ISC not and ISC 01 to 00, the low level of INT node generate an interrupt request. For the 01 configuration, any logic changes on INT node generates an interrupt request. For 10, the falling edge of INT node generates an interrupt request. And for 11, the rising edge of INT node generates an interrupt request. So in this diagram, if we press the switch, a high to low edge signal is generated during the press. So we'll select this option 1 0, and these two bits are part of the MCU CR register. So we have to clear the bit number 0 and we have to set the bit number 1. So the syntax MCUCR or is equal to 1 left shifted by ISC01 will set the bit number 1, and the syntax MCUR and is equal to not 1 left shifted by ISC00 will clear the bit number 0. And now we have to write ISR. So we want to toggle LED whenever the switch is pressed. So we have to write a command to toggle the LED. So for that we are doing XOR operation of port A with 1 left shifted by 0, or we are doing XOR operation with 0x01. So here we have to add one more statement. We have to configure the PA0 in the output mode.